Welcome to the deep dive. When you think of Stephen Hawking, what's the first thing that comes to mind?
For so many people, I think it's that image, isn't it? The wheelchair, the synthesized voice.
Exactly, and this just incredible mind exploring the cosmos. He wasn't just a physicist, he was, well, a real cultural icon.
He absolutely was. And today we're going to really dive deep into his life. His amazing theories, some we now know are true, others, well, they're still big mysteries. And his thoughts on, where humanity fits into it all.
Yeah, and to help us do that, we've pulled together some really fascinating stuff. We've got scientific papers, detailed biographies, discussions on his big books, even the story behind that famous voice.
Right. So this deep dive should give you a kind of multi-layered view of who he was and what he left behind.
Our goal here is really to pull out the key ideas, the most important bits of knowledge, basically a shortcut so you can feel well-informed about, well, one of the greatest minds of our time.
And hopefully you'll find some surprises, maybe a few aha moments along the way.
Okay, so let's get into it. Let's start with the man himself. What was his early life like? Were there early signs of the genius to come?
Well, it's interesting. He was born January 8th, 1942. And get this, that was exactly 300 years to the day after Galileo died.
Wow, really? That's quite a coincidence.
Isn't it? His family was very bright, maybe a bit eccentric. Apparently, meals were often silent affairs, everyone just reading their own book.
Huh, okay, that paints a picture. But, despite that intellectual atmosphere, I read he wasn't exactly a star pupil early on.
That's right. At St. Albans School, he was actually third from the bottom of his class.
No kidding. So what flipped the switch? What got him into science?
It seems it was a math teacher, Di Crontata. He really lit that fire. Hawking and some friends even built a sort of primitive computer using old clock parts and a telephone switchboard.
That's brilliant. Very hands-on.
Yeah, very inventive. And then at Oxford, he famously claimed he only studied about 1,000 hours over 3 years.
1,000 hours.
Yeah.
Seriously.
Yep. But he still managed to, project this daredevil image. He was a cox for the college rowing team, apparently steered them on some pretty risky routes.
Sounds like he had a bit of a rebellious streak even then. But then things took a really sharp turn, didn't they, in 1963?
They did. At just 21, he got the diagnosis. Motor neuron disease, ALS, Lou Gehrig's disease, just devastating.
And the prognosis was terrible. 2 years, they said.
Yeah, just 2 years. But he lived for another 55, passing in 2018, an incredible defiance of those initial predictions.
Must have been just unbelievably tough at first.
Oh, absolutely. He fell into a deep depression, understandably felt, what's the point of finishing his PhD?
But something changed.
Yes. And this is really interesting. Getting engaged to Jane Rylde in 1964, he said himself it gave him something to live for.
That makes sense. A reason to fight.
Exactly. And as the illness progressed, crutches, then the wheelchair by the late 60s, his speech, getting harder to understand his mind, just adapted in these amazing ways.
Wow.
He started visualizing things differently, seeing equations almost geometrically. One physicist compared it to Mozart composing a whole symphony in his head.
Wow. That's hard to even imagine.
It really is. And despite everything, he was fiercely independent. Always wanted to be seen as a scientist first, then maybe a writer, but, just a normal person. Jane apparently called his stubbornness either determination or sometimes just plain obstinacy.
I can believe that. That same drive probably fueled his work, right?
Yeah.
Moving on to his actual theories. Black holes are the big one, aren't they?
Definitely. That's what he's most famous for. Black holes came out of Einstein's general relativity, but for decades people weren't sure if they were, real.
So what was Hawking's big contribution there in the early 70s?
His genius was marrying Einstein's theory of gravity, the big stuff, with quantum mechanics, the weird world of the very small. Nobody had really managed to convincingly bridge that gap before, especially for black holes.
Okay, so he took these two huge, seemingly separate theories.
And wove them together. And that's what made black holes suddenly seem not just like a mathematical quirk, but like something that could actually exist out there in the universe.
And we now know they do. That first picture in 2019 from the Event Horizon Telescope.
Exactly. Seeing that image of the black hole in Messier 87, that was a huge confirmation of the theoretical work, including his. A really powerful moment.
Absolutely. Now, the name black hole suggests nothing gets out, right? Not even light. But Hawking found a loophole.
Sort of, yeah. He applied quantum theory right at the edge, the event horizon. He realized these pairs of virtual particles are constantly popping into and out of existence everywhere, even near a black hole.
Virtual particles, like not quite real.
Well, they exist for incredibly tiny fractions of a second, but Hawking figured, what if a pair appears right at the edge? One particle falls in, but the other escapes.
Ah, so the escaping one would look like radiation from the black hole.
Precisely. And that's Hawking radiation. A black hole isn't perfectly black. It glows very, very faintly and actually shrinks over unimaginable timescales because it's losing energy this way.
And this was controversial for a long time.
Oh, yes. Very debated. But recently there was this amazing lab experiment using an acoustic analog. Basically, sound waves in a special setup acting like light near a black hole.
And they detected it.
They detected the equivalent of Hawking radiation, sound waves being emitted exactly as his maths predicted. His formula for it is even on his gravestone now.
That's incredible. What a legacy. What about primordial black holes? That sounds different.
Right, so most black holes we think about come from massive stars collapsing at the end of their lives. But Hawking explored the idea that some could have formed spontaneously right after the Big Bang.
In the universe's first moments?
Yeah, from incredibly dense patches of energy in the early universe. These primordial black holes could, theoretically, be much smaller than stellar ones, though the tiniest ones would have evaporated by now due to that Hawking radiation.
And he thought they might be dark matter. That mysterious stuff making up most of the universe's mass.
He considered it, yeah. It was an intriguing possibility at tiny black holes floating around, providing the extra gravity we observe. But currently it seems unlikely to be the whole answer, and we just don't have the tools to spot them directly yet.
Okay, so that's still an open question. Which brings us to some of the more speculative ideas, the ones still up in the air, like the multiverse.
Exactly. Towards the end of his life, he was working a lot on the multiverse. The idea that our universe might just be one bubble in a whole sea of other universes.
But he wasn't keen on the anything goes version, right? Where, like, there's a universe where I'm a teapot or something.
Huh. Pretty much. He found the idea of an infinite multiverse where literally everything possible must happen somewhere, a bit messy, maybe philosophically unsatisfying. So his last paper with Thomas Hertog tried to tame it.
Tame the multiverse. How?
They proposed a mathematical framework suggesting the multiverse might actually be finite, not infinite, based on ideas from string theory.
But again, fascinating as it is, we can't actually test this, can we? We can't peek into other universes.
Not currently, no. It remains a theoretical possibility, deeply rooted in physics, but beyond our experimental reach for now.
Okay. And what about time travel? Did he think that was possible?
Well, this is another surprising one. Einstein's general relativity, the theory that describes gravity so well, doesn't actually rule out traveling backwards in time. There are solutions to the equations that allow for these things called closed time-like curves.
Which would let you loop back into your own past, like in the movies.
Potentially, yes. But Hawking really disliked the paradoxes this creates. You know, the grandfather paradox, going back and stopping your own birth, that kind of thing.
Right, it makes your head hurt.
Exactly. So he proposed the chronology protection conjecture. Basically, his guess, and he admitted it was a guess or a conjecture, was that some undiscovered law of physics must step in and prevent backward time travel from ever actually happening.
So a fundamental rule saying no paradoxes allowed.
Kind of. Most physicists tend to agree, thinking it's likely impossible. You'd probably need weird stuff like exotic matter with negative energy, which we've never seen and which seems to break other basic energy rules. So, probably not happening.
Okay, so time travel is likely out. What about the ultimate origin question? Before the Big Bang.
Ah, yes. Hawking's view is pretty consistent. Asking what came before the Big Bang is like asking what's north of the North Pole.
Meaningless.
Meaningless because, in his view, time itself began with the Big Bang. There was no before in the way we usually think of it.
And from that, he drew some pretty strong conclusions about a creator.
He did. He famously said, "For me, this means that there is no possibility of a creator because there was simply no time for one to exist before the universe began."
And in his book, The Grand Design, he went further, didn't he? Saying the universe created itself from physics alone.
Yes, he argued the Big Bang was an inevitable result of the laws of physics, specifically gravity, that the universe can and will be created out of thin air, essentially from the laws themselves operating on, well, nothing, or rather, the quantum vacuum.
How did that go down? Especially outside of physics.
Well, his physics colleagues mostly respected his scientific points. But philosophers, yeah, some definitely rolled their eyes, as one source put it, especially when he declared philosophy is dead.
Why the eye rolling?
Critics argued his claims, like his idea of model-dependent realism, where a good scientific model creates its own reality, weren't really scientific conclusions, but more like philosophical positions he didn't fully argue for. Kind of naive metaphysics, some said.
And his definition of nothing.
Right. Defining nothing as the quantum vacuum, which is actually a sea of fluctuating energy and virtual particles, was seen by some philosophers as sidestepping the deeper question. Why is there anything at all, even a quantum vacuum, instead of absolute nothingness?
Interesting distinction. He also had this no-boundary proposal, right?
Yeah.
With Jim Hartle.
Yeah, that was another fascinating idea about the very beginning. They suggested that if you could sort of look back towards the Big Bang, space-time wouldn't end at a sharp point or edge. It would be smooth and rounded, like the surface of the Earth at the South Pole.
No starting line, no boundary.
Exactly. And initially, Hawking suggested this meant God, if one existed, had no freedom or choice about how the universe began, because there wasn't a specific moment of beginning in that sense.
Wow. Okay, shifting gears a bit. Later in life, he made some pretty dark predictions about humanity's future.
He did, yes. Became quite vocal about potential threats. Things like the Higgs boson particle, potentially triggering a catastrophic vacuum decay that could wipe out the universe.
Yikes, that sounds bad.
Very. Also, hostile aliens he warned against actively trying to contact extraterrestrials, worrying they might see Earth as resources to be plundered.
The be quiet or they'll hear us argument.
Pretty much. And artificial intelligence. He was really concerned about superintelligent AI. Not necessarily that it would be malicious, but that its goals might not align with ours, and its sheer competence could lead to our downfall. He said success in creating AI might also be the last event for humanity.
That's chilling. Did he see any way out?
His big hope was space colonization, spreading out beyond Earth. He thought it was almost inevitable that something, nuclear war, climate change, maybe a pandemic, would cripple Earth within the next 1,000 years or so. So becoming a multiplanetary species was crucial for survival.
You really hope he was wrong about some of those timelines.
You certainly do. It's heavy stuff.
Let's talk about how he communicated all this, especially after he lost his voice. That synthesized voice is so iconic.
It really is. That happened after severe pneumonia in 1985 led to a tracheotomy. He completely lost the ability to speak naturally.
How did he manage initially?
It was incredibly painstaking. Just raising his eyebrows to choose letters on a spelling card held up by someone. Imagine.
Oh my goodness.
Oh.
Slow doesn't even cover it.
No. But then the breakthrough came in '86. A computer program called the Equalizer, made by Walter Woltos. It let him select words from a huge list using a hand switch.
And that generated the voice.
Yes, through a speech synthesizer. He actually joked he could communicate better afterwards than before he lost his voice because he could prepare sentences ahead of time.
And that distinctive American accent. He kept that one specifically, right? Even when technology improved.
He did. He said he preferred it. He identified with it. It really became part of his persona, didn't it? Shows how much even a synthetic voice can mean.
Absolutely.
Uh-huh.
But later, even using the switch became too difficult.
Yeah, as his condition worsened, he eventually controlled it using just a tiny muscle in his cheek. Communication slowed down dramatically, maybe one word a minute towards the end. Intel and others worked hard on predictive software to help speed things up.
Just incredible determination.
Yeah.
And that voice allowed him to keep lecturing, appear in popular culture.
Oh, massively. He became a global celebrity, didn't he? Largely thanks to A Brief History of Time back in '88. That book was a phenomenon.
Record-breaking bestseller list run, millions sold.
Yep. And he followed it up with The Universe in a Nutshell and A Briefer History of Time, trying to make these incredibly complex ideas accessible to everyone.
And the pop culture stuff. Star Trek, The Simpsons, Pink Floyd, The Big Bang Theory. He seemed to really enjoy it.
He definitely had a playful side. Remember him saying his ideal role would be a James Bond villain?
Yes. He said the wheelchair and the voice would be perfect. You could just picture it.
Agrees. Totally. He had a great sense of humor about himself. And of course, the movie The Theory of Everything brought his life story to an even wider audience, even using his actual synthesized voice in the film.
Beyond the science and fame, he also became an advocate, didn't he?
He did, particularly for people with disabilities, campaigning for better access and support, though he always stressed his main focus was science. He also spoke out on issues like assisted suicide for the terminally ill and did the Ice Bucket Challenge for ALS awareness.
And he wasn't shy about his political views either.
No, quite outspoken. A longtime Labour Party supporter in the UK, very critical of the Iraq War, pro-nuclear disarmament, He strongly backed the National Health Service, saying he owed his life to it.
And concerned about climate change, critical of Trump's policies, worried about Brexit's impact on science.
Yes, all of that. It's interesting, though, isn't it? This tension between his scientific determinism, his atheism, belief that physics governs everything.
And his engagement with very human, political, ethical issues.
Exactly. And even his language. He famously declared himself an atheist. No one created the universe and no one directs our fate. Yet he also used that phrase about wanting to know the mind of God if we found a complete theory of everything.
Which confused people, I think.
It did, but he
Huh.
clarified it. He meant knowing everything God would know if God existed, which, he stressed, he believed God didn't. He said you could call the laws of science God if you like, but it wouldn't be a personal God you could talk to.
A metaphorical God, then. The laws themselves.
Pretty much.
Yeah.
And finally, just thinking about his legacy and making his work accessible, Cambridge University is digitizing his archives now, right?
That's right. Handwritten notes, letters, photos, making it all available online, free to the public, which is fantastic. A lot of his academic papers were already out there on sites like ArcSwim, but this is much more personal, showing the whole journey.
It really opens up his world.
Yeah.
So wrapping this all up, what's the big takeaway for you, for our listeners? Stephen Hawking was, just a giant. He defied his physical limitations in ways that are hard to comprehend, and he fundamentally changed how we see the universe.
Absolutely. From confirming black holes exist, to figuring out Hawking radiation, to pushing boundaries with ideas like the multiverse and time travel.
Yeah.
His mind just went places others couldn't.
And he used that unique position, that fame, to talk about humanity's future, the big risks, the big opportunities, even while facing immense personal challenges himself.
He definitely pushed us to ask the biggest questions. About existence, about our origins. He believed science held all the answers. But maybe the provocative thought here is, does it?
That's the question, isn't it? Can science alone truly answer something like, why is there something, rather than nothing? Or is the fact that a human mind, especially one operating under such constraints as Hawking's, can even grapple with these cosmic questions, does that point to something more? Something beyond just the physical laws?
Whether you're searching for the mind of God or just trying to understand the universe's incredible design, Stephen Hawking's life is this powerful reminder, isn't it? That the quest for knowledge is just fundamentally human.
And that the universe, with all its complexity and mystery, is always there, just waiting for us to ask that next big question.